Hello everyone, welcome to my JE Physics channel. And in these days I found this question is very good one. Okay, so usually we see the rotation of one fluid, but in this case they have given the two fluids. Okay, so all of you go through the question and try yourself and come back for the solution. Yeah, before going through solution, we require some concept to solve this question. So let us see that concept. Suppose there is a one vessel. Okay, inside the vessel we have a this is cylindrical vessel, we have a liquid. If this liquid along with the vessel is rotated with angular velocity omega, then you will see that the surface of the liquid will make some curved shape. It's something like this. Okay, so this is completely liquid. So this is usually taught in the classroom. This is a regular concept only. So let us take this is x-axis, and if I am taking this is the y-axis. Okay, so then there will be some equation for this shape of the liquid. That equation will be omega square, let us say r square by 2g. So this is the equation for the shape. Okay, this is the what you require. Actually there will be some derivation which you I think you might have across, come across in the classroom. Now if any rotating fluid is there, let us say that there is one tube. Now this tube is rotating with angular velocity omega, and this tube is entirely filled with a liquid. If I am taking the 2 points A and B, okay, A is at a distance of x1, let us say B is at a distance of x2, then pressure difference between A and B can be written as rho omega square by 2 multiplied with x2 square minus x1 square. It's a pressure difference value I am saying. Now which one is more, which one is less? That depends on, usually what happens, there will be centripetal acceleration towards the axis. So this is way I do it usually. Whenever there is an horizontal acceleration, then the pressure difference between 2 points, or pressure difference or pressure value, you can say anything, along the acceleration decreases. Along the acceleration the pressure value has to decrease. So that's why PA will be less than PB. So if you want, you can write down PB minus PA value goes to rho omega square by 2 multiplied x2 square minus x1 square. So same the concept you can apply here. See, along the acceleration, let us say that towards the axis there will be acceleration. If you see the 2 points, okay, let us say this is the second point and first point, then there is a more liquid above the second and less liquid above the first one. So that means P2 is greater than P1. So along the acceleration the pressure value will decrease. That difference of pressure value will be given by this equation. So these are the two equations required to solve this question. Along with that, there is one more idea. The idea is, suppose as let us say that this is the one cylindrical vessel. If this cylindrical vessel is rotated with angular velocity omega along with the liquid, then liquid will take parabolic shape. Liquid surface will take a parabolic shape. So this in 3D, if you see this, we call it as paraboloid. Okay, it's a paraboloid. Now what is the volume of this paraboloid? If you calculate the volume of paraboloid, now you take the volume of cylinder in which paraboloid is present. Okay, let us say that paraboloid height is small h. Okay, then radius of the cylinder is r, let us say. Then entire cylinder volume, the cylinder volume is pi r square h. This is the cylinder volume. Then volume of this paraboloid, so volume of paraboloid will be half of cylinder volume. Okay, these are the three important ideas which you require to solve the question. Okay, one is the shape of the liquid while rotating, the second one is pressure difference while rotating, and the third one is volume of the paraboloid. Okay, so these are the three ideas required to solve the question. Let us go through the question now. Now if I, in the question what has given is actually upper part of the, upper part of the container is closed. Even obviously lower part has to be closed. It's a very silly thing. Okay, so this is the one liquid with 3 rho liquid, 3 rho density, and this is another liquid with rho. Obviously both are immiscible liquids and all the dimensions are given. Okay, Now the question is for omega 1 calculation. See, I think you might came across or you might have read the question. Okay, so please read the question carefully and try to understand, then you will understand the solution also. Omega 1 is the least possible value such that fluid of density rho is not in contact with curved surface area of the cylinder. This is an important statement to understand. So for curved surface of the cylinder, that means this one, side surface, that rho liquid should not touch this surface. Okay, then how to solve this? So you can draw the diagram in this way. Let us take, this is the cylinder. If this is the cylinder, then upper part is closed, so it's not open. Now rho liquid does not touch the curved surface of the cylinder. That means rho liquid has to take the shape something like this. Exactly, it should meet at the end point. So nowhere the side, you can say that curved surface, okay, side walls of the cylinder is in contact, means that is completed. This completely will be the liquid of density rho. So then remaining 3 rho liquid whatever is there, so that should be distributed in this way. Okay, remaining entire space is distributed with 3 rho. Okay, this is the idea. Now we need to find out what is the angular velocity. That angular velocity they have given omega 1. Now we need to identify the omega 1 first, so that we can go for remaining part of the question. Okay, first they are asking the omega 1 by omega 2 ratio. If omega is equal to omega 1 delta P, they are saying delta P is nothing but maximum possible Gauss pressure. So what is the Gauss pressure is nothing but the pressure above the atmosphere. Okay, so above the P naught. But actually there is a small problem in the question is what is the initial pressure of the system is not given. So let us take the initial pressure of the system at the highest point as P naught. Okay, so that is the one assumption you can say, or adjustment in the question, you can say anything. So that we have done. So please go through the question again if you don't understand anything. Okay, now what is this length? This length we don't know. Let us take as y. If I am taking this as y, we know that volume of the paraboloid. First of all, I am going with the volume. Then what is the volume of density rho liquid? Okay, if you feel that this explanation is little slow, please watch the video at 1.25 speed or 1.5 speed. So I think 1.25 is suggestible. Okay, then what is the volume of the rho liquid is? Rho liquid volume is pi into, so they have given this radius also h. Okay, so then pi h square into y will give you volume of cylinder by 2. This is the volume of rho liquid according to this shape. But actually what is the volume of the rho liquid as given? See, so volume of rho liquid as given as, you can check here, h is the height of the cylinder, r is the radius, then pi h square will be the area into h. So you will get pi h cube. Okay, so I can write down this one as what? Pi h cube. So previous volume, now this volume will be same because no liquid is spilling out. Then y value will get 2h. That means this entire length is 2h and remaining this length will be h. Total 3h is given. Okay, so that is the one conclusion we made. But we require what? Omega 1 value. So to know the omega 1 value, I am going to take different points. Okay, stick to me so that you will understand. Let us take that, see, on the axis there will be no change in pressure. So I am taking this is the P naught. Then I can calculate the pressure at this point. Let us take A point. Then what is the pressure difference between A point and P point along the same horizontal level? So in rotation of fluids, we know that pressure difference value. As we move close to axis of rotation, pressure decreases. So that's why I have taken the PA is more than P naught. Now I can write down that rho, because in between A and P rho liquid is there. Okay, omega 1 square, because omega 1 is the angular velocity we are taking. That's why rho liquid is not touching the side walls of the, what do you say, that cylinder, multiplied with, so A is at a distance of h, so h square minus 0 because P naught on the axis. Then difference I can write down rho omega 1 square h square by 2. Okay, this is PA and P naught relation I got. So once I know the PA and P naught, so I can take one more pressure difference, or else I'll take two more points. Let us take this is the B point and this is the C point. So I can apply the vertical pressure difference along the rho liquid, which is PB minus P naught is equal to, okay, rho into G into height value is actually Y according to my assumption. Y value is solved as 2H. Similarly, PC minus PB also I can write down. See, ultimately I am writing all pressure difference values. Then what is the PC minus PB value I will get? See, in between B point and C point, now we have a 3 rho liquid. So I can write down 3 rho into omega 1 square by 2 into, so obviously H square minus 0 square. So you will get 3 rho omega 1 square H square by 2. Okay, so these are the different pressure values we got. So this is PA minus P naught, this is PB minus P naught, this is PC minus PB, and again I can write down the PC minus PA also, which is vertically present. Then PC minus PA I can write down as, okay, now the liquid is 3 rho is present, 3 rho into G into height value is 2H. Okay, so if I am properly arranging all these things, so probably all will get cancelled out. Okay, so let us go. PA and PA will cancel out if I am adding them, okay, and P naught and P naught won't cancel, and PC and PC won't cancel, because if I am adding directly I am talking about. Okay, so now we need to do somewhere negative. What we do is, if I am going to subtract this, I am going to subtract, okay, if I am going to take minus sign of this, then minus will be there. It's a solving of equation, you can do anyway. Then minus PC, PC cancel out, plus PB is there again. This also I am taking minus, okay, then minus is there. Then minus PB plus PB cancel out, plus P naught cancel out, PA and PA cancel out. So everything will cancel out if I add them. Okay, so then on left side I'll get 0. So then these two are negatives and these two are positives. I can write down rho omega 1 square H square by 2 plus 3 rho G into 2H. You can write down 6 rho GH minus 2 rho GH. Okay, this value, and this value will be minus 3 rho omega 1 square H square by 2. Okay, so then I'll get, if I simplify this part, I'll get rho omega 1 square H square, because this is minus 3 by 2 plus 1 by 2, you will get one time. On this side I have taken positive, and this is 6 minus 2, it is 4 rho GH. Then omega 1 square I can write down, H cancel out, rho cancel out, 4G by H you will get. This is the omega 1 square value. Okay, once I know the omega 1 square value, then where do you find the highest pressure? Obviously at the bottom you will find the highest pressure, 3 rho liquid. So this is the corner where you find the maximum pressure. Then how to find out the maximum pressure value? Maximum pressure minus PA is equal to, I can write down 3 rho G into 3H, because at the bottommost point you will find the maximum pressure. At the same time, at the ends you will find the maximum pressure. PA will be more than P naught, PC will be more than PB. So that means highest pressure places will be this one corner, and I want the maximum pressure in the entire rotating fluid. So I need to take the point which is at the bottom. So then what is the maximum pressure? I can write down as PA plus 3 rho, so 9 rho GH. Now what is the PA value? PA value I can write down similarly, that P max is equal to PA value I can write down P naught plus rho omega 1 square H square by 2 plus 9 rho GH. Okay, so we have gauge pressure is required, highest gauge pressure is required. So gauge pressure is nothing but the pressure above the P naught, okay, more than P naught. So the gauge pressure value will be rho H square by 2 into omega 1 square I can write down 4G by H plus 9 rho GH. So you will get 2 rho GH plus 9 rho GH. Okay, so then it is 11 rho GH. So this is the gauge pressure under the condition of omega 1. Okay, so let us see, the first option will be what? If omega is equal to omega 1, the gauge pressure we are getting 11 rho GH. Yeah, so we got the 11 rho GH. So option 1 will be correct. Okay, first option will be correct. let us go with for omega 2. Okay, this will be little interesting. So maybe video is little lengthy, but definitely you will learn something from this. Then omega 2 is the angular velocity for least possible omega, such that fluid of density rho is in contact with the base of the cylinder. Okay, so this rho liquid has to touch the base. Now now you pause the video, you try to draw the diagram for this. This is really a good idea, okay, to understand or to learn. So that's why I have taken this question actually. Okay, so the first rho liquid has to touch the base. So I'm going to draw the diagram. Okay, carefully follow this. Now this is the cylinder. Now rho liquid has to touch the bottom. If it is touching the bottom, then rho liquid won't be in touch with the side walls. Now it has to shrink. Okay, so now it is touching the bottom, so the rho liquid has to take the shape something like this. Okay, so then this is the axis at which the entire liquid is rotating with angular velocity omega 2. But we don't know what is this radius. I am taking it that radius value is r. So let us check. Now what I am going to apply is, I am going to apply the first scenario, the shape of the what do you say that surface of rotating fluid. Okay, so y is equal to omega square r square by 2z. So that I am going to use here. So now I don't know what is the radius r. Okay, but if I am applying the parabolic equation, then what I am going to get is, then y is equal to omega square r square by 2g. Then obviously y value will be 3h, because entire this height value is 3h, is equal to omega 2 square r square by 2z. Okay, so this is the one equation, and the second equation I can go for volume. If I am taking the cylinder which is containing the rho liquid, so now imagine a cylinder of radius r. This entire cylinder is occupied with the rho liquid. Not entire cylinder means like cylinder is containing the rho liquid. Don't misinterpret. Okay, not entire volume. Inside the cylinder, this entire rho liquid is present. Okay, so then I can write down that volume of rho liquid is pi h square into h. This we know already, pi h cube is equal to half of the cylinder volume, which is half into pi r square 3h. Okay, because 3h is the height of the cylinder is 3h, r is the radius. So half of the cylinder volume will be the paraboloid volume. Already we have taken that. So that's why I am using the volume conservation here. So if I am going with the volume conservation, I will get r square is equal to, then it is 2h by 3, 2h square by 3. Yeah, h and h cancel. So pi cancel, 2h square by 3 you will get. So then r value is equal to root 2 by 3h. Okay, that means from here to here, the radius, distance of the rho liquid at the highest point will be root 2 by 3h. This we are going to apply later. Now we need to identify the omega 2 value. Then how to go for omega 2? This is little require calculations. So let us go through this one by one point. Okay, so let us take this point as P naught. This already we know. Now we take this is the A point. Let us take this is the B point. So all I am taking along the same horizontal level. Now what is the PA minus P naught goes to? PA minus P naught is nothing but only rho liquid is present. So I can write down rho omega 2 square by 2 into, this is r square minus 0, x2 square minus x1 square. Now we identify the pressure difference between B point and A point, which are along the 3 rho liquid. So I can write down PB minus PA can be written as what? 3 rho omega 2 square by 2 into, okay, so the distance of B point is h, so h square, minus distance of A point is r square. Okay, if I am adding these two, I will get PB minus P naught, which can be written as what? Rho omega 2 square by 2. If I take common, then it is r square, okay, plus 3h square minus 3r square. Okay, by 2 we took common. Then I will get rho omega 2 square by 2 into, this value is 3h square minus 2r square. Okay, So then PB minus P naught can be written as rho omega 2 square by 2. Let us simplify this part. Okay, 3a square minus 2r square. R square is nothing but 2a square by 3. Then it will become 4a square by 3. So then you will get 9 minus 4, you will get 5 rho omega 2 square h square by 2, no 6. Okay, one more 3 will be there, 2 3s, okay, it will be 6. Okay, so 6 will be the pressure difference. From this we can identify the PB value. So P naught plus 5 rho omega 2 square h square by 6. Once I know the PB, I can go for maximum pressure in the entire cylinder. Obviously that is the bottommost point and corner point. So this is the point related to maximum pressure. Okay, so then maximum pressure can be written as, or maximum pressure minus PB, which is vertical pressure difference I am writing, 3 rho into G into, again height is 3h. So you can write down simply 9 rho GH. Then what is the maximum pressure possible in the entire rotating liquid is, PB is nothing but P naught plus 5 rho omega 2 square h square by 6 plus 9 rho GH. So from this we can identify the maximum Gauss pressure. So obviously this term goes to maximum Gauss pressure in the rotating whatever given system. Okay, but to identify this value we require the omega 2 value. So for that what I am doing is, I am considering two more points. One is at the axis at the bottom, other is again maximum pressure point. Let us name them as C and D, let us say. So then what is the pressure difference between C and D? So obviously PD is more than PC, is equal to, now the rotating liquid will be 3 in between these 2 points. So 3 rho omega 2 square by 2 into, one is at h distance, other is at 0. Then PD minus PC, or else PD is equal to PC plus, PC plus, this I can write down 3 rho omega 2 square h square by 2. Now we can find out the PC value by using vertical pressure difference along the axis. Then PD can be written as, in the place of PC I can write down P naught plus rho G into 3h. This is the vertical pressure difference I applied along the axis. See, PC entire height is 3h and liquid is rho, plus 3 rho omega 2 square h square by 2. Now I got pressure difference at D point, which is nothing but maximum pressure. Even I got the maximum pressure from here also in this equation. So we have two equations for maximum pressure. So if I am equating, I can find out the omega value. So if I am equating, obviously P naught cancel out. So remaining terms I am writing. So 3 rho GH plus 3 rho omega 2 square h square by 2 is equal to, this value is 5 rho omega 2 square h square by 6 plus 9 rho GH. Okay, so then if I take on this side, then it is 3 by 2 minus 5 by 6 into rho omega 2 square h square. Okay, because I have taken 3 by 2 and 5 by 6. It is 9 minus 3, it's a clear value of 6 rho GH. Rho cancel, rho cancel. Okay, this value goes to 6 means 9 minus 5, 4 it is. 4 by it is 6. Okay, omega 2 square h is equal to 6g. Rho and h cancelled out. Then it is 2 and 3 okay. Then omega 2 square goes to, which is, again you can cancel. Okay, so this is 9g by h. This is omega 2 square value. Once I know the omega 2 square value, I can go for Gauss pressure, maximum Gauss pressure. So what is the maximum Gauss pressure is? Maximum Gauss pressure is equal to 5 rho by 6 omega 2 square, 9g by h multiplied with h square plus 9 rho gh. So then I'll get h cancel, it is 3 2 then it is 15 rho gh by 2 plus 9 rho gh, 18 plus 15, it is 33 rho gh by 2. So obviously this is not the answer, I feel. Let us check. Yeah, so omega is equal to omega 2, delta p is not 21 times. Now we have to go for the omega 1 and omega 2 relation. What is the omega 1 we got? 4g by h. Okay, omega 2 9 g by h. So then what is the relation? Omega 2 I got 9 omega 2 square, 9 g by h. Then omega 1 by omega 2 goes to, obviously g by h cancel, under root, it is clearly 2 by 3. So that means omega 1 by omega 2 is 2 by 3. Okay, so that means D option correct and A option correct. So hope you enjoyed the video. Please like and subscribe, and that will motivate me for more number of videos. And obviously the question will be little tougher side, I accept it, but if you don't learn like this, it is very tough to crack the JEE Advanced exam. Okay, so please stay tuned to channel for good questions like this. Thank you so much.